Hi, today I'm going to be entering the contest hashtag make it float using the model you see in front of me. If you continue watching, I'm going to be sharing with you the process of how the process I took to get this model achieved over here and print it into a tangible object. Okay, so what you are looking at here in front of us is the prototype 1 of the make it float boat. And as you can see, there's not much of a difference here between the newest model and this model, but instead there are tiny little changes and minor changes into it. So the front of here, the tip, actually became more aerodynamic in the other one, and the sides were a more streamlined design. But the main problem wasn't the aerodynamics for the second prototype. It was actually the bottom, and I found that the bottom had minor little holes in it that water could seep in if I printed this out. So it'll be easier to see it in Kira. So here's the same model in Kira, and in the bottom you can see the little holes that I found that could potentially let water in, and it's not a completely flat surface. You could see right there, it's quite a thing there. So then I came over and made a prototype 2. If we take a look here, you can see that this side over here is way thinner than this piece over here, right? Not this side, this piece over here is way thinner, and that's because it was made that thin over here so that the settings that I'm going to use afterwards to print it with, the printer will not be able to print that area since it's that thin, and it'll come out as a door. I found it easier if it was like that, because if we actually did cut a hole here, it may not be flat at the bottom, and we may have the problem of the holes again, which I didn't want to get into. So I just made it extremely thin, and it should come out as a hole later on for our door. But before I made the prototype 2, I tried using a different program to actually seal up the holes, which was called NetFab. I tried to repair the object in NetFab, and it didn't work out. So here's the object that I tried with NetFab. Okay, so the model that I accessed on NetFab was this one right here, using this program. So if we take a look at this in Kira, because it's easier to see, let me load the model. This one, you could see that the holes are still there, and it didn't actually help it seal it. So that was a problem, because that was the main problem over there. So I tried using 123D design again to seal the bottom. Over here, if I open it in 123D design, this one, if I open it in 123D design, open, let's see, browse. This one, this was the one that I sealed by myself in 123D design without using actually repair tools or anything, and it actually worked out. So you might not be able to see this easily in 123D design, but if I actually move this up like that a bit and zoom in, you can see that there are no holes. So let me bring this over to Kira, and let me show you that. Load model file, bottom sealed. So this is the one that I was talking about, and the bottom has no holes at all. I completely sealed all the holes in the bottom, so I'm pretty sure no water will actually leak in anymore in this model. But then I wanted to go for a more creative and streamlined design, because you know, a lot of boats now that are designed these days are more energy efficient, and if we see here, this model is not energy efficient at all. There are a lot of not rounded edges, like say here, this extra little part will block wind if we were actually to blow steam on it. steam will actually not go around this as well as the newer model. So let me show you the newer model. So if I show you the newer model, though, in 1-2-3D design, it'll look like this. So this is the model in the newer model in 1-2-3D design. You might not be able to see all the changes, but the major changes are the tip right here. As I mentioned in the beginning, it became more aerodynamic by just a little bit. And over here, the major difference is right here. Over this extra piece here was actually molded into that shape, which is a lot more aerodynamic, as you can see over here. And also, if we take a look at the back, right here, this area was rounded a bit more, just a little bit more, not that much. And over here was molded up so the water can escape easily. Okay, so we're here in the Lulzbot edition of Kira. This is my preferred slicer. So let's get printing. So first of all, I want to rotate the model 90 degrees so it's facing forward as it prints, so it can have a nice view of it as it's printing. And next we're gonna go over to load profile, open profile, and we're gonna select the profile that I want. So we're gonna hit profile, and we're gonna choose PLA Medium Mini because we are gonna be printing in light blue PLA filament. Okay, so it's gonna load. As you can see, it takes 9 hours 46 minutes for this print to come up, but we're gonna make it a lot shorter since we don't need the fill density up to 20%, but we could keep it at 3% because we want this to be a quite hollow area in the pontoon area, this pontoon and the other two. We're gonna set it to a 3% fill density. That will make it have a lot of air pockets inside, so it'll make it better at floating, which is exactly what we want. We don't want it to be dense because we want the water to stay denser than the pontoon itself and the boat. So we're going to keep it at 3% infill, and it became 6 hours and 30 minutes. So let's turn on the printer over here. You might be able to hear it in the background. Let's control. Everything else here can stay the same. And then we're going to set the print temperature to 200 degrees and the bed temp to 60 degrees for PLA, and we should be good. So let's test everything if it's working. Yep. And let's see the print head if it's going to work. Yep, the print head works too. And let's home everything. Perfect. Once the temperature is up, and we should be printing. Alright, so the print took around 6 hours and 29 minutes, and I just wanted to let you know that the next part to this video is going to be a time lapse, but if you do not want to watch the time lapse, you can skip it. It's only around 3 minutes long, so skip it if you like. There's more after the video where I'm going to be doing an experiment of testing how many coins it can hold, so you should stay tuned and watch that. Alright, so the object just finished printing. As you can see, it came out perfectly. The door came out perfectly over here. The letters over here came out perfectly. Hashtag make it float. The bottom came out perfectly, and it was a 3% infill, so this thing can actually float. Very detailed everywhere. No supports were actually used, so this makes it a very easy to use model. It was very easy to take it off the base, and it was printed in PLA plastic, light blue. Alright, so I got a couple of coins over here, and we're gonna start seeing how well this thing actually floats. So let's place it into the water over here, and it floats perfectly fine just by itself. So if we put one coin in, we're just gonna keep placing it until it can't hold it any longer. So that's one coin, 2, 3/4, 4/4, 5/4, 6/4, 8/4, 9/4, 10/4, 11/4, 12/4, 13/4, 14/4, 15/4, 16/4, 17/4, and I'll be right back. 17/4, 18/4, 19/4, 20/4, 21, 22, 23. Let's see the other side. So it's completely floating still completely over the surface. Let's put more coins in. Let's put one at the front. And it's nothing. There's no water going over the pontoons right now. If I could show you just quickly over here, there is no water over the pontoons, and all the water is still below the pontoon. So this part over here is still completely dry, and we're gonna place coins until it goes over, and we'll see how many more coins we can put until it reaches this part. So let's continue on. I need to get more coins though. Alright, so let's add more coins. I got a whole bunch more. Let's see how many we can add until it goes over this part. Alright, okay. So we got a little water over there right now. Let me show you. Let me zoom in as close as possible to that. We got a little water over there. And that's how many coins it can hold before water goes over that pontoon over there. And let's see on the other side. Alright, so the other side is still fine. So that means we got a little bit too many coins on that one side. So let's see if we can balance it out and see if it can stay. So let's put some more coins on this side before I place it back in. Oops. Alright, so I was able to balance it out back, and we're going to keep adding coins until it goes over the large pontoon, this one. Alright, so I'm back with even more coins this time, and let's see how much we can add until it fills over the large pontoon. Alright, so that's about how much it can hold until it actually completely lost balance. And I'm going to see how many coins there are, so I'm going to subtract one out of all the coins in there, because that was the one coin. This was the one coin that I added in that made it fail. I'm going to add it in and see how much it weighs altogether. Okay, so I'm going to dry the coins out now so it doesn't weigh as much, because once the coins are wet they weigh more, so I'm going to dry them out for the perfect result. Alright, so I got an electric scale here, and I got the coins that were placed onto the boat, and I got the boat here for us to weigh. And first of all, let's weigh how much one of these quarters are. But remember, I'm weighing the exact same coins that were before, because this coin and this coin may not have the same weight as each other. So to be exact and precise for this experiment, we're going to keep this out. We're going to keep the same coins that we had in the past from this weighing experiment. Okay, so to prove that this coin does not weigh as much as this coin, we're going to weigh each one. So let's turn on the scale. Let's zoom into the scale first. Alright, let's lock the tripod. Okay, so here's this coin, and this coin is approximately 5 grams. It is 5 grams. So let's see how much this coin weighs. And this coin is 4 grams. So these two coins do not weigh the same. Probably it's because of the extra paint on here. I don't know. So let's get weighing. Let's start stacking these coins onto the scale. Okay, so I finished weighing placing all the coins onto the scale, and these coins weigh 211 grams. That's 211 grams these coins weigh altogether. So now let's see how much the boat weighs. Let's place this boat on top. So this boat weighs 102 grams. This boat is able to carry over double its weight, and that's what a boat is supposed to do. A boat is not supposed to carry less than what it is, it weighs itself, because the boat is supposed to be light, right? And you want your boat to be as light as possible so that you can carry more, at the same time have the speed and use less fuel and be more fuel efficient. Overall, this boat performed pretty well in the experiments that it was tested in. It was able to hold a total weight over 2 times its own. That was exactly what I wanted to achieve when I modeled this boat. Although this boat may not have the speed as many other boats, which was affected by the design, it doesn't have to. The contest was designed so people can create a boat that holds coins. If we put that to ratio, it is like a cargo ship carrying containers. Those ships don't move very quickly. I hope you enjoyed this print and experiment, because I know I did. And remember, #make it float.